Hello and welcome to Mechlin 360. In this video, I want to explain to you how to resolve a force into space in space giving the unit vector between 2 points. So let's try to illustrate the principle of a force and a unit vector along the line of action of the force between 2 points A and B. So let's see. All right, so I have point A, I have point B in space. Now I have a line joining A and B right there, and then the force is acting on this line. So this force can be any force at all. It could be tension or any other way, but we are looking at a force acting on the line joining 2 points A and B. Now we are saying that, so to find the component of the force along the x, y, and z axis, we will define a unit vector along line AB joining the points A and B, right? And so let's look at vector AB. So what is a unit vector actually? We want to look at a unit vector. So a unit vector is nothing but a vector divided by its magnitude. That's actually a unit vector. Okay. Now let's look at, so let dx, dy, and dz represent the distances measured along the x, y, and z axis from A to B. So what we want to do is that we want to work from A to B and then describe a unit vector. That's what we want to do. So I'll do dx along the x direction, I'll do dy along the y direction, I'll do dz. So in other words, what we are trying to say is that stand here, walk, you can do anything you want, but at the end of the day, you will walk from here to here, from here to here, then from here to here. You can even decide to go this way, and then go this way. You can even decide to start here, go all the way here, step down, come here, go up. It's the same thing. But in everything you will do, you will be describing movements along the x, y, and the z. And then that's what we actually say. Alright, so let's say after walking from A to B, you did dx along the x, dy along the y, and then dz along the z. So this is what we are saying. What is the magnitude? The magnitude is going to be the square root of dx squared plus dy squared plus dz squared, isn't it? And so let's assume that the magnitude is d. So if the magnitude is d, then I can represent lambda as the vector over its magnitude. So the vector is the dx in the I plus dy in the j plus dz in the k divided by the d. Now what we are trying to say is that, okay, so I've been able to look at the unit vector from A to B. Okay, so that is what we have over here. So let's recall that whenever I have a force and I have the scalar, I can resolve the force into a vector or rectangular component when I multiply the scalar of the force by a unit vector in the direction of the force. So I will multiply the scalar of the force F by a unit vector dx over d, dy over d, dz over d. D here is actually the magnitude. Alright, so clearly I can factorize d out. D is here, d is here, d is also here. So clearly I can factorize d out. Then I can say that comparing with the initial equation we have developed, now I've done a video on direction cosine, so you can look at direction cosines as well. I'll leave a link below for direction cosines. Now, looking at this carefully and comparing it with what we have here, then clearly we can say that the fx is also f. So if I say that f, so what we are trying to say that we can compare this to this and say that, okay, so the x component is f dx over d, and the y component will be f times dy over d, and the z component will be f times dz over d. So basically that's what we are trying to say. And then also we can also say that the cosine, so cos theta x is going to be dx over d, cos theta y is dy over d, and cos theta z is dz over d. And so this is how to resolve a force into components giving 2 points, and then the force is along a line joining A and B basically. So thank you for watching.